welcome everybody. This is Moon Characteristics Part 2, video number 85. I'm only going to talk for part of this, and then I'm going to show you a couple clips from NASA, so make sure you take some notes of those as you go along. Alright, so let's talk about that moon dust. So the moon dust covers the surface of the moon. It's made of basalt, remember, bringing back your rocks here, and a few other minerals. What you're looking at here is actual footprint from one of our astronauts. I wanted to show you a moon map. In fact, just like we would here in the United States, you actually can have locations that are named. And I wanted to show you a whole bunch of them. Some of the ones that are my favorite: Sea of Rain, Sea of Clouds, although I don't know if you're in the Sea of Crisis, that's probably a bad thing. And there actually is a place called Burkeland on the moon. So I not only have my own element, Burke-Gilliam, I have my own place on the moon, Burkeland. Yay! So here's one more video clip. I wanted to show you guys some actual footage of astronauts actually walking on the moon. Alright guys, hope you enjoyed that first clip. Now I'm going to show you a second video clip. This one's from NASA, and it's going to show you how our technology has helped us evolve and know more about our moon. So hang tight, hope you enjoy it.
To nearly everyone, the moon appears to be a sterile, gray, unchanging world. But while the moon has remained largely unchanged during human history, our own understanding of it has evolved dramatically. Thanks to new observations, we now have not only unprecedented views of its surface, but a whole new tour of the moon that shows how both it and other rocky planets in our solar system have been shaped over billions of years. We'll start with one of the largest impacts, Oriental Basin, a feature that's as wide as the distance from New York City to Cincinnati. Using new elevation measurements, we can clearly see the effects of what is likely the last giant impact event in lunar history, with its outer mountain rings rising many kilometers above the lowest points inside the crater. The interiors of some craters in the moon's polar regions, like Shackleton, haven't seen sunlight in over 2 billion years. However, new measurements have created our best yet maps of these types of craters, allowing us to see deep into the shadows of this surprisingly young-looking impact crater in the south that's more than twice as deep as the Grand Canyon. Some impacts are invisible for other reasons. Although the ancient South Pole Aitken Basin is difficult to see from orbit because it is so large, new LRO topography maps reveal the largest impact basin in the Earth-Moon system, measuring several kilometers in depth and around 2,500 kilometers in diameter. Only the Hellas Basin on Mars rivals it in size. Our first stop is the Compton Belkovic region, which shows evidence for young volcanic activity in the far side highlands. This feature is unique not only because it is isolated from other volcanoes in the area, but also because it is located nowhere near the Maria, where volcanoes are usually found. Also, on the far side, we find the Jackson crater, which, like the Tycho crater on the near side, has an extensive and complex ray system. In fact, this crater is often considered to be like a twin to Tycho. Finally, the Tsiolkovsky crater stands out as an excellent example of a far side crater filled with a sea of ancient lava, known as a mare. It is particularly interesting to scientists and other observers because of its isolation from other similar craters, as well as its beautiful central peak. As we continue to study the moon, our understanding of it improves, giving us new insights not only into how it has evolved over time, but also how other rocky planets in our solar system have come to look the way they do. With new missions, new instruments, and new technologies, we will continue to improve our knowledge of the moon and better understand the history of our solar system.
Summary time. So I'd like you to compare and contrast the land features found on the moon to the land features here on Earth. Those two video clips should have helped quite a bit with that. And then I've got an opinion question for you. Should we develop the moon? Meaning, should we put houses and developments and things like that? Should people live on the moon? Why or why not? And then this is a bonus question. Go Google for me. When was the last time anybody visited the moon? What year and who was it? You might have caught it. I did say it once in the video, but you might want to just Google it and see what you can tell me. As always, thanks for watching. I hope you enjoyed the funny, and may the force be with you.